A lone worker, high above the desert floor, tightens a final bolt on a massive steel girder. Below him, miles of concrete and rebar stretch into the haze, an entire city block in scale, yet utterly devoid of buildings. This colossal framework, intricate and immense, is slowly being swallowed by the earth itself, buried beneath tons of rock and soil. Its purpose, a secret so profound, its existence was denied for decades. For these engineers, the challenge wasn't just to build, it was to build and then make it vanish, to create infrastructure on an unimaginable scale that, by design, would never be seen. This is a story of engineered invisibility, of projects so vast and so sensitive they reshaped landscapes and redirected rivers, all while remaining hidden in plain sight. From underground railroads designed for mail, to command centers carved into mountainsides, engineers have, throughout history, been tasked with monumental projects that must operate in the shadows. We're going to explore 9 of these engineering marvels, each a testament to human ingenuity and the profound demand for secrecy. Each project presents its own unique challenge. How do you move mountains without anyone noticing? How do you construct a vast network beneath a bustling city without disrupting life above? And what secrets do these hidden structures still hold? ####9, the London Mail Rail. Our countdown begins beneath the bustling streets of London, where a lesser-known railway system once hummed with activity, unseen and unheard by the millions above. Imagine an underground network, not for people, but for parcels, running 22 hours a day, 6 days a week, at speeds up to 35 miles per hour. This was the London Mail Rail, or the Post Office Railway, a 6.5-mile-long subterranean electric railway system that connected Paddington to Whitechapel. Construction began in 1914, digging tunnels with a diameter of roughly 9 feet, using the shield tunneling method, a technique pioneered for the London Underground, but adapted for this smaller, bespoke system. The challenge was immense, excavating through saturated clay and gravel beneath historic buildings, all while ensuring no surface subsidence. The engineers employed segmented cast iron rings to line the tunnels, installed immediately after the shield advanced, creating a watertight, stable bore. Over 27,000 individual tunnel rings were used. Each station was effectively a miniature underground railway depot, with conveyor belts and sorting offices built directly into the cavernous spaces, some over 100 feet below ground level. The entire network was powered by a 75-volt DC third rail system, allowing for driverless trains controlled from central signal boxes, a truly revolutionary automated system for its time. From 1927 until its closure in 2003, it transported an estimated 4 million letters a day during its peak, a hidden artery of commerce that only a handful of postal workers ever saw. Its secrecy wasn't about espionage, but about efficiency and discretion, a massive logistical machine operating silently beneath one of the world's busiest cities. ###8, the Cheyenne Mountain Complex. Now, picture a mountain, solid granite, standing guard over Colorado Springs. Within its heart, engineers carved out a colossal underground city, designed to withstand a nuclear blast. This is the Cheyenne Mountain Complex, home to NORAD, North American Aerospace Defense Command, and USNRTHCOM. Its construction, starting in 1961, involved removing over 700,000 tons of granite, creating 14 buildings housed within massive steel caverns. The sheer scale of excavation required innovative techniques. Instead of traditional drilling and blasting, which would have shaken the mountain and revealed the project, engineers used a method of slash and burn, drilling precise boreholes and using controlled charges to fragment the rock, then mucking out the debris. The crucial engineering element for blast protection is the system of 1,333 giant springs, each weighing 1,000 pounds, upon which the entire complex rests. These springs isolate the internal structures from the shock waves of an external impact. Imagine dropping a massive anvil on a trampoline. The trampoline absorbs the impact, protecting whatever is placed on it. In this case, the trampoline is an array of enormous spring-supporting structures that collectively weigh over 62,000 tons. The buildings themselves are modular, steel-framed boxes, designed to flex rather than break under extreme stress. Furthermore, a series of blast doors, each weighing 25 tons and designed to seal automatically within 20 seconds, guard the two main tunnel entrances. These doors are so robust they could withstand a 1 megaton nuclear detonation just outside. The secrecy was paramount, not just during construction, but in its ongoing function as the nerve center for continental aerospace defense. ###7, the Gihon Tunnel. Travel back 3,000 years to ancient Jerusalem, where a vital engineering feat ensured the city's survival during sieges. The Gihon Spring was Jerusalem's primary water source, located outside the city walls, making it vulnerable. King Hezekiah faced the challenge of securing this water supply without alerting potential besiegers. His solution was monumental: the Gihon Tunnel, an underground aqueduct over 1,750 feet long, carved through solid rock. What makes this project truly astounding is that it was dug simultaneously from two ends by two separate teams, working towards each other through solid rock, relying on sound and basic surveying techniques to meet in the middle. Imagine excavating with bronze tools and oil lamps, navigating by the sound of your fellow miners on the other side, through rock that could collapse at any moment. The tunnel averaged 6 feet high and 2 feet wide, just enough for a single person to walk through and for water to flow. The slope was carefully engineered to allow water to flow consistently downhill, a drop of only 1 foot over its entire length. This precision, achieved without modern instruments, is a testament to the sophisticated understanding of hydrology and surveying held by ancient engineers. The tunnel redirected the Gihon Springs water into the Pool of Siloam, safely within the city walls, rendering the city self-sufficient during extended sieges and making a crucial resource invisible to enemies. ###6, the underground aircraft factories of World War II. During World War II, as Allied bombing campaigns intensified, Germany faced a critical problem: how to continue aircraft production without factories being obliterated. The answer lay beneath the earth, in massive, purpose-built underground facilities. Projects like Mittelwerk near Nordhausen were carved into mountainsides and disused salt mines, becoming colossal subterranean factories. At Mittelwerk, the engineers utilized existing gypsum mines, extending them into a labyrinth of tunnels over 2 miles long, with main galleries reaching widths of over 60 feet and heights of 25 feet. The sheer volume of rock removed was enormous, often without heavy machinery due to wartime constraints, relying heavily on forced labor. The tunnels were reinforced with steel arches and concrete linings where necessary, creating a stable environment for production lines. The most incredible aspect was the installation of full-scale assembly lines for V-2 rockets and Junkers Jumo jet engines, deep underground. This included intricate ventilation systems to remove exhaust fumes and maintain air quality, power generation, and lighting for thousands of workers. The challenge was not just structural, but environmental, maintaining consistent temperature and humidity for sensitive manufacturing processes, even with thousands of people and machinery operating in enclosed spaces. The sheer audacity of moving an entire industrial process underground, hidden from aerial reconnaissance, highlights the desperation and ingenuity of wartime engineering. ###5, the hydroelectric tunnels of Norway. Norway's rugged terrain and abundant rainfall have made it a world leader in hydroelectric power. But many of its most powerful dams and power stations are deliberately hidden, tucked away deep inside mountains. This secrecy wasn't for military reasons, but for resilience and operational security, often a Cold War mandate to protect critical infrastructure. Take, for example, the hydroelectric complex at Kvildal. The engineering here involves constructing colossal tunnels and cavernous machine hulls thousands of feet beneath the surface. The headrace tunnels, which carry water from reservoirs to the turbines, can be many miles long and over 30 feet in diameter. These are excavated using advanced tunneling machines, like tunnel boring machines, TBMs, which grind through rock with rotating cutter heads, or by drill and blast methods for harder, fractured rock. The trick is maintaining structural integrity over such immense lengths and ensuring a smooth flow of water to minimize friction losses, which can amount to significant energy waste. The Kvildal power station, for instance, has a generating capacity of over 1,250 megawatts. housed in a cavern deep inside the mountain. The tail-race tunnels then carry the water back to a lower elevation. The sheer scale of these tunnels, sometimes big enough to drive multiple trucks side by side, combined with their hidden location, ensures that a critical national power source remains impervious to surface threats, silently generating electricity for millions. Which of these machines would you least want to be standing next to during construction? Tell me below. #4, the Suez Canal's hidden bypass channels. When ships traverse the Suez Canal, they pass through one of the world's most vital maritime arteries. What many don't realize is the extensive network of hidden bypasses and auxiliary channels, constructed and expanded with considerable secrecy over decades to improve traffic flow and reduce bottlenecks. These aren't just minor detours, they represent significant excavation and dredging operations designed to vanish into the landscape when not in use. The most recent expansion, completed in 2015, involved creating a new 35-kilometer channel running parallel to existing sections, alongside the deepening and widening of others. This massive undertaking involved the excavation of over 250 million cubic meters of sand and clay, requiring a fleet of dredgers working 24 hours a day. The engineering challenge was maintaining the structural integrity of the canal banks, composed primarily of unstable sand, while constantly dredging, and preventing erosion from the wash of passing megaships. Engineers employed geotextile barriers and revetments, protective structures like rock or concrete mattresses, along the banks to stabilize them. The hidden aspect isn't about physical concealment, but about the strategic invisibility of these operational redundancies. When not in active use for two-way traffic or bypassing a stalled vessel, these channels appear as extensions of the surrounding desert, only revealing their true purpose when the operational demand arises, allowing the canal to handle over 18,000 ships per year. #3, the Derwent Valley Aqueduct System. Far beneath the picturesque Peak District in England, a network of tunnels and aqueducts, some nearly 2 centuries old, quietly channels water to millions. The Derwent Valley Aqueduct System, built between 1902 and 1916, is a vast, largely hidden infrastructure project designed to supply drinking water to cities like Sheffield, Nottingham, Derby, and Leicester. The system relies on a series of reservoirs, Howden, Derwent, and Lady Bower, high in the valley. But the journey of the water doesn't end there. From these reservoirs, water travels through a complex web of tunnels and conduits, some up to 11 feet in diameter, burrowed deep into the hillsides and under rivers. These tunnels, often excavated by hand in the early 20th century, presented enormous challenges in terms of geology. Engineers encountered everything from solid gritstone to soft, waterlogged shale, requiring constant adaptation of tunneling techniques, from blasting through rock to carefully propping up unstable sections. The crucial trick was maintaining precise gradients over many miles to allow gravity-fed flow, avoiding the need for expensive and energy-intensive pumping stations. This often meant constructing cut-and-cover sections, digging a trench, building a conduit, and then burying it again, to create a perfectly level path where tunneling wasn't feasible. The aqueduct system, largely invisible save for occasional access shafts and valve houses, ensures a consistent, clean water supply, a silent marvel of early 20th century hydraulic engineering that most people drink from daily without ever seeing its source. #2, Project Iceworm and Camp Century. In the icy expanse of Greenland, during the height of the Cold War, the U.S. Army embarked on a secret project that sounds like science fiction, Project Iceworm. The goal was to build a network of mobile nuclear missile launch sites under the Greenland ice sheet, protected from Soviet attack. While the missile base itself, named Camp Century, was ultimately deemed unfeasible, its construction was a monumental feat of concealed engineering. Beginning in 1959, engineers carved a network of tunnels and facilities out of the permanent ice sheet, over 200 miles inland from the coast. This wasn't just digging, it was mining ice. Giant snow cutters, specifically designed for the project, were used to excavate trenches, some over 26 feet wide and 25 feet deep. These trenches were then roofed over with arched steel culverts, which were then covered with excavated snow, forming stable tunnels and domes within the ice. The entire camp eventually comprised a network of over 3,000 feet of tunnels and facilities, housing up to 200 personnel, complete with laboratories, living quarters, a hospital, and even a portable nuclear reactor for power generation. The critical engineering challenge was dealing with the plastic flow of ice, the phenomenon where ice, under immense pressure, slowly deforms. Engineers had to constantly monitor and reinforce tunnels, anticipating and mitigating the creep of the surrounding ice, which eventually doomed the project's long-term viability. The entire base was designed to be eventually swallowed and crushed by the ice, leaving no trace. The secrecy around Camp Century was total, making it one of the most remarkable and audacious attempts at covert infrastructure in history. ###1 The London Cold War Bunkers and Exchanges. Our top spot takes us back beneath London, not for mail, but for survival. During the Cold War, a secret network of hardened bunkers and vast underground telephone exchanges was constructed to ensure the continuity of government and communications in the event of nuclear war. These weren't just simple shelters, they were entire self-sufficient complexes, designed to operate for months in isolation. One of the most extensive was Kingsway Telephone Exchange, a massive series of tunnels located over 100 feet below the High Holborn area. Originally designed as deep-level air raid shelters in World War II, the complex was repurposed and expanded in the 1950s and 60s. Engineers constructed several miles of tunnels, some large enough to accommodate small vehicles, connecting to a vast, multi-story underground facility. This included dormitories, offices, a deep well for water, air filtration systems to remove nuclear fallout, and crucially, an immense automatic telephone exchange that could process millions of calls. The sheer scale of the internal infrastructure, including ventilation shafts running hundreds of feet to surface disguised as innocuous street furniture, was staggering. The tunnels were reinforced with thick concrete linings, designed to withstand significant shock waves. The complex featured blast doors, identical in design to those at Cheyenne Mountain, weighing many tons, to seal off the facility. The true engineering genius lay in integrating these vast, hardened spaces into the existing, dense urban underground without anyone on the surface realizing the true purpose or extent of the construction, a secret kept for decades until its partial declassification.